Hello everyone, Wireless Communication and Networks. Myself, Mr. Karthik, Assistant Professor, Department of Electronics and Communication Engineering. Today I am going to explain about the co-channel interference and system capacity. Co-channel interference and system capacity. In a previous session, we discussed about what is the frequency used, what is the handoff, what are the fundamentals of cellular mobile communication. We discussed in the previous session. But in the today's session, mainly we focus on the system capacity and also what are the different types of interference we will discuss in this session. Okay, before that we have to see the what student will learn. Okay, the student should be able to learn the functioning of cellular system for implementing the technical challenges. Okay, with the help of these cellular enhancements, cellular improvements and system capacity, then they know the function of the implementing the cellular system. There are also the technical challenges. Okay, coming to topic, interference and system capacity. What is meant by interference? Okay, interference is a major limiting factor. Major limiting factor. If you go for any signal, the performance based on the interference only occur. Okay, but interference is a major limiting factor in the performance of cellular radio system. Okay, then again we have the different types of interference. Okay, what interference will be, what are the problems that we will see. Before that, we can see source of interference include the another mobile in the same cell. Okay, how the interference will occur in the cellular radio system. Okay, that we have to see the what is the source. Okay, for that, mobile in the same cell. Okay, another mobile in the same cell. Then the interference will be occur. A call in a progress in a neighboring cell. This is another factor. Okay, the first factor is the receiver same in the same cell. Otherwise, call progress in the neighboring cell, and also other base station operating in the same frequency band. Then the frequent interference will be occur. These are the factors, and also we have the one more thing. Any non-cellular system which involuntarily leaks energy into the cellular frequency band. Okay, these are the source for the occur the interference. The first one is the same another mobile in the same cell, call progress in a neighboring cell, or otherwise the other base station operating in the same frequency band. Then the interference will be occur. Okay, these are the source for the interference. Okay, this is a major limiting factor, and also with the it is based on that interference, the performance of the cellular system also will be having. Okay, once we will see the interference and voice channels, it causes the crosstalk. When the interference will be occur, what are the problems in the cellular mobile system? Okay, the previous one is the source of interference, how the interference will be occur. Then after the interference will be occur, what are the problems in the cellular system? First one is the crosstalking, where the subscriber hears interference in the background due to an undesired transmission. Okay, in the real time also you observe. Okay, whenever you're talking with a phone with another friend or another person, sometimes some noise will be occur. That is an undesired transmission signal. Okay, the crosstalk also will occur. The signal will jump. Okay, those are the factors for the interference. And control channels interference leads to mislead and blocked calls due to errors in the digital signaling. Coming to digital signal, only mainly many interference will be occur. Those are the different types. Okay, interference is more served in urban areas due to the greater high frequency noise in the floors and also the large number of base station and mobiles. Okay, there also mean coming to suburban areas and urban areas. Okay, mainly urban areas having the more interference because here we having the buildings, high use buildings and trees. Okay, the based on that the propagation will be changed. Then the interference will be occur. Interference has been recognized a major bottleneck in increasing capacity and often responsible for dropped calls. Okay, actually, what is the topic? Improving the system capacity. Okay, this is a one disadvantage interference. The based on the interference, that is system capacity will decrease, and also is also respond for the dropped calls. Sometimes hang up call also will be there. Call cannot be connected. Those are the thing we are observed from the interference. Okay, coming to two types of system generated cellular interference. The first one is a co-channel interference, and second one is the adjacent channel interference. What is the first one? Co-channel interference, and second one is the adjacent channel interference. Okay, in the previous slides, what we discussed, what is the interference, what are the source for interference. After that, what it causes the interference. Okay, and then this one is the what are the types of interference, how interference will be occur in the co-channel interference and also adjacent channel interference. The first one is the co-channel interference. Coming to frequency use, it implies a given coverage area. There are several cells that in the same set of frequency. If you go for the frequency use concept, okay, already we discussed about the frequency use concept. Go through that particular video, then you can understand the frequency use concept. There also we use the same frequency in the particular base station nearby cell. Okay, then that is a concept for frequency use. But here you can see that some set of frequencies, it implies the given coverage area. These cells are called co-channel. What is mean by co-channel? The same frequency, the same set of frequency having the same cells, that is called co-channel interference. Okay, co-channels, and the interference between the signal from these cells is called co-channel interference. Okay, if for example the several cells that has the same set of frequency. For example, here this is a cell, this is a cell, this is a another cell. For example, here K cell, K frequency, here also K frequency. Okay, here also same K frequency. This is the same set of frequencies. Okay, these cells are called co-channel interference. Sorry, co-channels. These cells are called co-channel. Whenever the interference will be occur in the same set of frequency, that interference is called co-channel interference. Co-channel interference. Okay, that is called co-channel interference. Okay, unlike the thermal noise, which can be overcome by increasing the signal to noise ratio, that is a SNR, co-channel interference cannot be combated by simply increasing the carrier power of the transmitter. Okay, one more thing, co-channel increase cannot combat the increasing the carrier power of a transmitter. Okay, whenever we want to increase the capacity, we need the improving the signal power also. Okay, and also reducing interference, then we only improve the capacity of the particular system. Okay, here this is the co-channel interference. What is the co-channel interference? Means whatever having the same set of frequency cells, whatever having the same set of frequency in cells, those cells are called co-channels. Okay, in between the interference occur in between those cells is called co-channel interference. Okay, this because increasing the carrier transmitter power and also increase the interference to neighboring co-channels. Whenever we go with the co-channel interference, it reduces the co-channel interference. Co-channel cells must be physically separated by minimum distance to provide sufficient isolation due to propagation. What is meant by propagation? The propagation is nothing but transmitting or traveling source to destination. Okay, while traveling, transmitting the signal from transmitter to receiver, the whatever having the cells, it having the sufficient distance, separate physically, it having the sufficient distance, then we can remove the particular co-channel interference. Coming to here, we can see how we can find out the co-channel release ratio. Okay, for that we can consider the radius of the cell. For that, consider the radius of the cell and distance between the nearest cells, nearest co-channels. Okay, for example, we can consider the one geographical area. Here we having the different cells. here we having the different hexagonal shaped cells, different we having it. Okay, here we can find out the radius of the particular cell and also the distance between the two different cells. Okay, then we can go with the D. You can find out the D and also R. Okay, by increasing the reuse ratio D by R, we know the D, we know the R, that is a D by R. The spatial separation co-channel cells related to coverage, the distance of cell is increased. Thus, interference is reduced from improved isolation of high frequency energy from the core channel cell. Okay, here you can consider whenever we go for the size of the each cell, that is approximately the same channel of the base station transmitted the same power. Then we can find out the channel reuse ratio by increasing the reuse ratio of D by R. We know the what is the D? D is the between center of the nearest co-channel cells and also radius is R. We can find out the co-channel interference ratio. Here, what is the formula? Okay, the parameter. Okay, the parameter Q called co-channel reuse ratio. This is a co-channel reuse ratio. What is the formula? D by R, and also we can write root 3 n. Okay, this is a hexagonal geometry because here we considering the hexagonal shape. We already see in the previous sessions what is a cell, what are the different types of cells, why we go for the hexagonal shape. Okay, then we finally find out the accurate shape for the signal propagation or cell coverage area. This is a hexagonal shape. Okay, coming to here, you can see the cluster size. What is mean by cluster? Cluster is a group of cell. Okay, group of cell is called cluster. Okay, this is a group of cells. Okay, this is called cluster. For example, we have to find out the Q value, reuse ratio Q equal to D by R, R equal to root 3 n. Okay, here they given the cluster size. Then we can find out the whenever the cluster size n equal to 3. Okay, then Q equal to root 3 into 3. Then we get the 3. The cluster reuse ratio is 3. Like that, n equal to 7, Q equal to root 3 into 7. Then we get the 4.58. N equal to 12, Q equal to root 3 into 12 equal to 36. That is the reuse ratio 6. And n equal to 13, Q equal to root 3 into 13. Then we get the 6.24 Q. That is a reuse ratio. Okay, based on the cluster size, we can find out the co-channel reuse ratio. Then we get the D by R equal to root 3, and also we can write. Sometimes they given the two cells distance between the coverage area and also cell radius. Then we go for the this formula D by R. Otherwise, whenever they given the cluster size, go through like this. Okay, this is one formula. And also one problem we have see here. If a signal to interference ratio 15 dB is required to satisfactory for forward channel performance of a cellular system, what is the frequency reuse factor and cluster size that should be used for maximum capacity if the path loss exponent it is n equal to 4 and n equal to 3. This is a and this is a B. They given in the question. Assume that there are 6 co-channels cells in the first tier and all of them are the same distance from the mobile. Use suitable approximations. What is the reuse ratio formula? We know it already. Q equal to D by R equal to root 3 n. If they given the cluster size, we can go it like this. Otherwise, we can go with the D by R. Okay, here what is the given data? Interference ratio is the interference ratio is 15 dB. Okay, it is required to satisfactory of the channel performance. Okay, then they have to give the what is the cluster, we can assume cluster size, and also we can go with the reuse ratio. Then what that value it is satisfactory to the 15 dB, we have to find out. Okay, for that we can consider the assuming they told use suitable approximations. Then we can go with the, for example, a is a n equal to 4, a is a n equal to 4. Then we can assume 7 cell cluster, we can assume 7 cell cluster. Then signal interference ratio s by I equal to, then we know it, what is the q equal to root 3 n. Finally find out the 4.583. In the previous slide we find out already, whenever q equal to root 3 into 7, then we get the 4.583. 583. Then the signal to interference ratio s by I equals to, that is in the session they given the 6 co-channels in the first type, 6 co-channels in the first type. Then we can write what are the co-channels here in the first type, 1 by 6 into, then root q value, that is a 4.583 into n equal to 4. Then we can write value, then we get the 75.3, and also we can convert into dB because they given in the signal to interference ratio their satisfaction 15 dB. Then we can write the into dB 18.666 dB. Whenever we convert into dB 20 log or 10 log, we get the 18.66 dB. Then this is satisfactory to the given required signal to noise interference ratio. Okay, there we get the 15, this is greater than to 15 dB. Then this n equal to 4, 7 cell cluster is okay, no need to go for the another cluster. Okay, like that we can find out the same thing for b equal to b n equal to 3. Same we can use the 7 cell cluster. Okay, 7 cell cluster. Then we can write s by I equal to 1 by 6 into, that is a q value 4.583 whole power of 3 because they given n equal to 3. Then we get the, here we can see n equal to 3, then we get the 16.04. Then we convert into dB 12.05 dB. Okay, then this is not satisfactory to the 15 dB, the required satisfactory, it is not required, it is not satisfactory, then less than, this is a less than 15 dB. Okay, this is not satisfactory. That's why we can use another cell cluster, because you can observe here, whenever you go with the n equal to 4, the first one, when we go for the approximately standard size of n7 cell cluster, then we can substitute the signal to noise interference ratio, that is clusters first tier in the cluster size, into reuse ratio whole power of n. Okay, then we get the 75.3, then we can convert it to dB, then we get the 18.66 dB. Then this is the required satisfactory value is greater than, then we can go with the cluster size n equal to 7, capital N equal to 7. Then same thing, they asked for n equal to small n equal to 3, the 7 cell cluster size we can assume, then s by I equal to 1 by 6 into 4.583 whole power of 3, then we get the value 16.04. Okay, we are converting to dB, that is having the 12.05 dB. This is not satisfactory to the required signal interference ratio. Then we can go with the capital N equal to 12. Okay, we can see, otherwise if it is not satisfactory, then we can go with the n equal to 13. Okay, n equal to 12 means here the q value equal to 6. Okay, then what is this, how we get the 6? Q equal to root 3 n, that is a root 3 into 12, 36, that is a value is 6, q equal to 6. Okay, same thing we can find out here. Interference ratio, signal to interference ratio, this is a 1 by 6 into 6 power of 3, because b is a n equal to 3. B is a n equal to 3. Then we get the whole cube. Then what is the answer? 36. In converting to dB, 15.56 dB. Okay, this is satisfactory to the given required signal to interference ratio. There you can see 15 dB. Okay, here the first case it is satisfactory. Coming to in the second case, not satisfactory. Coming to here, the 15.56 dB is satisfactory to the particular required signal to interference ratio. Okay, this is a problem we have to find out in the co-channel cells. Okay, like this we can go with the another adjacent channel interference. Actually, co-channel interference and adjacent channel interference types of two types of the interference. Okay, that is the first one. Now we can see the adjacent channel interference. Okay, coming to co-channel interference means same set of frequencies in between, having the co-channel in between, the signal will be getting any problem, that is called co-channel interference. Okay, coming to adjacent channel interference is resulting from signal which are adjacent in frequency to desired signals is called adjacent channel interference. This is the adjacent channel interference, which are adjacent frequency desired signal is called adjacent channel interference. Okay, adjacent channel means that is a neighboring channel. Okay, adjacent means neighboring channel is a adjacent channel where the frequency will be occur in the adjacent channel, that is called adjacent channel interference. It results from imperfect receiver filter which allow nearby frequencies to leak into the passband. Then the adjacent channel interference will be occur. Okay, you can see here the problem can be particularly serious if adjacent channel user is transmitting very close range of subscriber or receiver. Then only adjacent channel interference will be occur. Okay, in the previous method, what are having the same set of frequency cells, then the interference will be occur in between, that is called co-channel interference. Here, very close range of subscriber, that means the same transmitting to the closest or nearby or neighboring cells. Then at time the some receiver attempts the receiver base station, the desired channel, then the time only adjacent channel interference will be occur. This is refers to near far effect. Also, we can also called near far effect. Okay, where nearby transmitter which are may or may not applicable to the same type of frequency used by the cellular system, it captures the particular receiver of the subscriber. Okay, coming to another factor for the system capacity, improving the and also reducing the interference. Whenever we reducing interference, we can increasing the system capacity. Both are vice versa. Okay, in a particular cellular radio system, personal communication system, that power levels transmitted by every subscriber unit under constant control by the several serving base stations. Serving base station means whatever having the transmitted signal from the base station, that is a serving base station. This is done you ensure that each mobile transmit a smallest power necessary maintain a good quality link and the reserve channel. Power control not only help the prolong battery life and for the subscriber unit, it also dramatically reduce the reverse channel of the signal to interference ratio in the particular system. Okay, the power control is not for only increasing the or prolonging the battery life in the subscriber, but also it go for the reducing the reverse channel of the signal to interference noise ratio. Sorry, signal to interference ratio. That's why we go for the power control for reducing interference. Okay, one more topic is trunking and grid up service. Okay, up to now we discussed about the what is interference, what are the source for interference, what are the what it causes the interference. Okay, and also after that we go for the types of interference. Okay, those are the fun topic for the interference and also improving the system capacity. The next one is trunking and grid of service. Okay, here both are two different, trunking and also grid of service. Coming to trunking, cellular radio system rely on trunking accounted the large number of users in a limited radio spectrum. You can observe this point. It accommodates a large number of users in a limited radio spectrum. Okay, limited radio spectrum, we can hook up to the large number of users. Okay, this is a trunking. The concept of trunking allows large number of users to share the relatively small number of channels, so by providing access to each user on demand from a pool of available channels. Coming to radio trunking radio system, each user is allocated channel per call basis. Per call basis only, they will allocate the large number of users in a particular limited radio spectrum. Okay, and also we can go, it will take from the pool of available channel. If the pool of the available channel is free, then it pick up the particular per call basis radio system. Okay, it upon the termination of the call, the previously occupied channel is immediately returned to the pool of available channel. For example, the trunking accommodated to the A subscriber. Okay, A subscriber. When the A subscriber terminate the call again, it return to the pool of available channel to the trunking system. Okay, this is the trunking. Coming to here, we having the different statistical parameters, different cat6 for the trunking. Here we can go with the statistical behavior users, so that fixed number of channels circuits may accommodate large number of random user community. Okay, the trunking theory determines the number of telephone circuits need to be allocated for office buildings with 100 of telephones, and the same principle using the designing the cellular radio system. Okay, for example, here how the telephone circuits will be allocated. The same thing go with the cellular radio system. Okay, the next one is a grid of service. Okay, what is the trunking? Trunking is we can accommodate the large number of users to a small radio spectrum. Okay, coming to grid of service, here it can handle specific capacity to a specific grid of service. The essential understanding the trunking theory and also queuing theory. Okay, here it can understanding the two theories. One is a trunking theory and also queuing theory. The fundamentals of trunking theory were developed by Erlang. Okay, actually trunking theory is developed by Erlang. Okay, those are the traffic intensity units. Traffic units are the Erlangs. Okay, we having the Erlangs are the units. The name itself. Okay, by the researcher. Then we can go with the Erlang units. A Danish mathematician Erlang is a Danish mathematician. He find out this one in the 19th century. The study of the how a large population could be accommodated by a limited number of servers. Then we can find out the trunking. Okay, the units are Erlangs. Okay, coming to the having the one scenario. Today the major traffic intensity base in is name. So that is Erlang. One Erlang represents the amount of traffic intensity carried by a channel that is completely occupied. For example, here you can see call per hour or call minute per minute per minute. Otherwise, we can find out the hour per hour, or otherwise minute to minute. For example, radio channel that is occupied for 30 minutes during the carries 0.5 lines. For example, here it carries 1 hour means 1 Erlang. That is means 60 minutes. Then 60 minutes equal to 1 hour, 1 Erlang. Okay. For example, 30 minutes means half an hour. Then we will get the 0.5 Erlang of traffic. Okay, clear? This is an example for the traffic intensity in the particular area. Okay, coming to here, you can observe. Okay, here observe. This is the number of cars passing through the intersector of the streets or cars per hour, cars per hour basis. This is a time of hour. Okay, for example, here we can consider the 24 hours. Okay, here a single day we are taken. Coming to here, the calls the 08th hour, that is 12 a.m. There we having the 1292 calls. Okay, and also coming to 2 o'clock, that is 1162. Coming to 4 o'clock, 864. Coming to 6 o'clock, those are increasing. The calls are increasing from the 6 o'clock onwards. that is a 4,618. Coming to 8 o'clock, that is a 9,999. In between the 8 to 10, they'll be having some little bit call dropping. Then also afternoon session, and coming to 2 o'clock. Then you can again increase the by 4 p.m. It again increase the 4 p.m. That is 10,980. Then that is constant to the 6 p.m. also. Then we go with the 8 o'clock and also 10 o'clock. That also gradual changes. This is one analyzing the calls per hour into the particular time of the traffic intensity. Okay, you can observe here the traffic intensity offered each user equal to the call request multiply the holding time. That is a formula is a AU equal to lambda H. Okay, here H is the average duration of a call and K is the this is a lambda is the average number of calls per unit. Okay, this is a AU equal to lambda H. This is the average call duration. This is the average number of call requests per unit time. Here AU is the total user generates traffic intensity. Okay, each user generates traffic intensity AU equal to lambda H. Okay, for that we can see for a system containing U, that means users and also unspecified number of channels, the total traffic carried intensity equal to AU equal to UAU. This is a AU equal to lambda H. This is a each user traffic intensity. This is a total traffic intensity A equal to U into AU. Okay, and also we can see with the help of channels, the triangle system, the traffic is equally distributed among the channels. Then the traffic intensity per channel is given by AC equal to U into AU by C. Okay, here U is the total traffic intensity. This is each traffic intensity. These are the channels. Okay, then we can go with the particular AC channel triangle system. Okay, for example, here we can see the one problem. Here we can find out the traffic intensity. How many users can be supported for 0.5% blocking probability for the following number of truncated channels in a blocked call clear system? For example, A 1 channel, B 5 channel, C 10 channel, D 20 channels, E 100 channels. Here you can assume or each user generates 0.1 erlongs of traffic. They given in the question. Okay, they want to know the A equal to 1, B equal to 5, C equal to 10, D equal to 20 and E equal to 100. These are the available channels and also traffic intensity each user means AU equal to 0.1. Okay, then we can find out the how many users can support. Then we can find out the EA. Here we can find out the U value. Okay, how we can find out the U value? AU equal to, then the previous one, A equal to U into AU. Okay, U into AU. From that we can find out U equal to A by AU. Okay, like that we can find out here. Then we can once we'll see how we can find out the blocking probability, and also we can find out the A value. How we can find out the A value? Because AU is given 0.1 erlongs. AU the given 0.1 erlongs. Then from that we need A value. Okay, how we can find out the A value means that is from Erlang B table or Erlang C table. We can find out from the Erlang B table and also we can find out the Erlang C table. Once we can see here, this is a Erlang B traffic table. Okay, here the what is the blocking probability they given 0.5%. 0.5%. Then one channel means they having the 0.0050, and also they are asking 5 channel. 5 channel means 1.132. Next 10 channel means 3.960. Next later 20 channel means 11.09. Okay, and also they are asking for 100 channel, then 80.91. Okay, these are all values we can find out from the Erlang B table. Here we can find out the A. Okay, A is a 0.0050, and also 1.132 and 3.960 and 11.09 and 80.9. Okay, this is for one channel, two channel, sorry, 5 channel, 10 channel, 20 channel, and 100 channel. For that A value. Okay, these are values from the Erlang B table. Then we can move on to the problem. Then for the A equal to one channel, okay, what is how many users allocated to the this particular one? Then we can go with the C equal to 1 AU. They given in the question, each user traffic intensity 0.1 Erlangs and the grade of service is the 0.005. Okay, then we can find out the A. From that A value from the Erlang B table, that is a 0.005. This is from the Erlang B table. Erlang B table. Okay, then we can substitute what is the need U equal to A by AU. What is a U? A 0.05 by 0.1. Then we get the 0.05 user. It is approximately one user. At approximately one user. Then like that we can go for the B equal to 5. That means C equal to 5. AU equal to 0.1 Erlangs. Grade of service same 0.0005. Then A equal to, we are from the Erlang B table, that is a 1.13. Then we can substitute U equal to 1.13 by 0.1. Okay, it approximately 11 users. At approximately 11 users. Okay, like that we can find out the C equal to 10. That is a C equal to 10. Next one, C is the C equal to 10, and that is a grade AU equal to 0.1 Erlangs, and the grade of service is the same 0.0005%. And also here we can find out the for 10 channels A equal to 3.96. Okay, then we can find out the U equal to 3.96 by 0.1. Then we get the 39 users approximately. 39 users approximately. Then D equal to C equal to, then D values are D, C equal to 20 channels. Then AU equal to 0.1 Erlangs, and the same thing, grade of service equal to 0.5005. Then A equal to, how we can find out the A value from the Erlang table, 11.10. Then we can substitute here U equal to 11.10 by 0.1. Then approximately 110 users. Approximately 110 users. Like this, same thing for 100 channels. AU equal to same 0.1 Erlangs. Okay, grade of service equal to 0.0005, and then each total traffic in users equal to A equal to 80.9. Then U equal to 80.9 by 0.1. Then A approximately 809 users. Okay, this like this we can find out the particular total traffic intensity. Okay, here how many users supported for the 0.5. That's why you can go with the U. Then AU, A by AU will find out. Okay, the same thing from the number of channels they given in the question. Okay, like this we can find out the trunking and data service. Okay, thank you. In the next session we can go for the another topic.
Like, share and subscribe. Hit the bell icon for more updates.